Okay, so in the last lesson, we went over how to do cross-type communication in JavaScript using local storage. Today, we're going to be going over how to do the same using a shared worker. Just like last time, there's a repository up on GitHub. I will have the link down below where you can clone down 00 start here. This contains the base code for each of the 3 different lessons. You can go ahead and clone that down. Once you have that cloned down, jump into your terminal, install the single dependency we have called serve, and then run npm run serve to get your local server up and running. Once you visit your server's URL, you should be welcomed by a screen like this. Go ahead and jump over to the shared worker page, and this is where we'll be working today. Like I mentioned in the last lesson, local storage is the most browser compatible way to go about this of the 3 methods we're going to be covering. Here is what the browser support currently looks like for shared workers. So shared workers are very similar to just using a normal web worker, except they're shareable across different browser instances, so tabs and windows. Much like web workers, we're going to need to create a script which we point to create our worker instance. And then once we have that set up, it's just a matter of sending and receiving our messages. Okay, so let's go ahead and jump into our editor. Let's jump into Pages, Shared Worker, Index.html. This is where we're going to be working today. The same as with local storage, we have a navigation followed by our heading, followed by a not completed yet div that we can now get rid of, our form for sending a message, our form for clearing messages, and our ordered list for displaying our messages, as well as a placeholder if we don't have any messages. We have a couple constants here and a couple of utilities here to help speed things along. We'll be using all of these except for getArrayDifference. These were copied over from the local storage, so you can go ahead and get rid of getArrayDifference. And let's start out by kind of demonstrating how shared workers are going to work. So just like we saw in the MDM documentation, we need to create our worker. So we'll do const worker equals new shared worker, and then we need to point it to a URL where our worker is going to reside. Okay, so now you can call this poor planning, but the dependency that we're using to run our code on our local server, I have pointed towards our pages directory. So anything outside of that pages directory, it kind of doesn't see. So for our shared worker, in order for our server to be able to locate it, we're going to need to create our shared worker inside of our pages directory. So let's go ahead and create a new folder inside of pages called scripts. And then inside of scripts, let's do a new file, and let's call this just SharedWorker.js. And this is where all of our worker code will reside. So now, as stated in the MDM documentation, if you use add-event-listener to listen for your message events, you're going to need to run port.start to start listening for those events. Otherwise, if you extend your event listener using the onMessage property off of your port, you won't need to explicitly call port.start. This is the method that we're going to use today. Okay, so everything communication-wise within our worker is going to reside within this onConnect function. Okay, and then if we jump back to the MDM documentation, you can see we accept an event for this onConnect function. And then our web server is going to be run off of a single port, so we really only care about that first property as well. So we're going to be copying that line pretty much verbatim. So const port equals e.ports 0 to grab the first index. And then let's go ahead and rig up our onMessage event handler. So port onMessage equals function, take the event, and then it's within here that we send the message out to our different browser instances. So for the purpose of getting set up, let's just focus on a single browser instance to keep things simple until we understand what's going on. So as kind of prep work for what we'll end up with, let's go ahead and just create a message counter so that we can kind of see how the flow of this is going to work. So let counter equals 0. And then every time that we receive a message, let's just increment our counter. And then within our connected port, let's send out our message. So let's do post message. And then we'll just send out a string for right now. Counter is counter, so that we send out a string with the current count. Go ahead and give that a save. Okay, and then now that we have a basic shared worker created, let's jump back into our index.html and point our shared worker to our shared worker script. So this is going to be scripts SharedWorker.js. Give that a save. And then let's jump into our browser and start playing around with this. So let's go into our localhost server, give it a refresh. Okay, let's jump into the console here, extend that out. Okay, and then since we defined our worker on the global scope, we should be able to play around with it here on the browser. So let's do worker.port. And then much in the same way that we added an event listener using the onMessage property within our shared worker, we're going to do the same here within the browser. So onMessage takes a callback function that accepts an event. And then within here, let's just console.log out our event.data. So the event that's passed through to our onMessage callback function contains the property of data. Data is the information that we're sending to and from our shared worker. So let's go ahead and set that. So anytime that we do worker port post message, data is the message that we pass within here. So in this case, e.data should be testing. So let's go ahead and send that. And you can see our counter got incremented. Let's go ahead and send that again. You can see it got incremented again and again. So it seems to be working just fine here within our single browser instance setup. Let's go ahead and open up a new browser instance here and see what happens if we open up our console on here, come back into here, and send another message. We can see we got it on this browser instance, but on this one, nothing happened. So now if we jump back into our code, we can see the reason for that is because we are listening and sending events off of a single port. So in essence, you can think of these ports every time that you're connecting as browser instances. So above our counter, let's do let browser instances as an empty array. And every time that we run onConnect and we grab the port that we're connecting to, let's push that port into our browser instances. So browser instances push port. And then instead of dispatching our message on the single port that we're connected to within this instance, let's dispatch across all browser instances. So we can do browser instances, we can loop over it, grab the single instance, and we can do instance that post message counter is counter. And then we can get rid of this line right here. Give that a save. Let's jump back into our browser. Let's close one tab, refresh one tab. Since we're using a shared worker, these workers are shared across all tab instances. So in order to refresh that worker, we kind of need to completely kill all tab instances. So in order to do that, we close one tab, refresh the single tab that we have open, and then open a second tab back up. Let's get back to our console there. Let's jump back to this tab and try sending a message again. Okay, so back within our initial tab, we need to redefine our onMessage event handler. And while I'm here, I'm just gonna go ahead and copy that. Let's define that there and define it on the other tab as well. And you can see there, defining our event handler on this tab already sent out that event. So looks like that's already propped up and working. And then let's go ahead and do worker port post message testing, and we should see counter is 2 on both tabs, and there we go. So it seems to be working just fine. We can copy that line and paste it from our other tab just to test. Counter is 3, should see that on both tabs, and there we go. So this is really all that we need for our core code base for our shared worker in order to be able to communicate across our different browser instances, whether that be tabs or windows. So now that we have the core code covered for this, let's go ahead and move into how to do our message-based system using the same approach. So instead of tracking counters here, let's go ahead and track our messages. So let's do let messages equals an empty array. Since we know within our onMessage event handler, all that we care about is the data within our event, we can extract that out of our event. We can get rid of our counter here. And then to kind of keep things clean with what we're doing and to extend the functionality beyond just posting messages, let's add the ability to define what we're doing with that message, whether we're adding or setting it or clearing it. So to do that, let's define some mutations here. So const mutations. Let's have a key called add, and let's have a key called set. These two mutation types here are going to cover both of the use cases that we're going to need. So whenever we're adding a new message, we're going to use the mutation add. And whenever we're either clearing or we're defining our base starting point for our messages, we're going to use set. So for our use case here, our data property is going to be an object that contains the mutation that we're doing, as well as the message value with which we're changing. To determine how to handle our onMessage event here, we're going to define a switch for data.mutation to determine which mutation type we want to run. Then we'll have case mutations.add to handle our add mutations. And so here we can do messages equals, spread it out, messages data.value. You can also just do messages.push data.value. We'll break our case, move on to the next one, mutations.set. And we're going to use set to define the entire value of our messages array. So for this, we just overwrite messages with data.value, and then we'll break that case. And now within our shared worker, it's also perfectly valid to define external functions outside of your onConnect. So we can do function. Let's create a post message handler that accepts in our message. And then within there, we can plop our posting messages to our different browser instances. And then instead of post message with our string, we'll post message with our message. And then let's also make sure that the data that we're posting out of our shared worker is the same type. So for our add mutation, our data.value type is an object. And for our set, it's always going to be an array. So let's wrap our object for our add mutation in an array, should that be the mutation that we're running. So if not array.isArray message.value, let's just do message.value equals array of single message.value. And then below our switch, let's call our post message function. So post message will spread out data so that we just define those properties within there. And then let's add in messages. So whenever we're sending data into our shared worker, our data is a property of mutation containing our mutation type, as well as a property of value containing the value of the mutation type that we want to set. So whether it be a single message object or an array of message objects. And then whenever we're sending data out of our shared worker, it's going to be the exact same, except we're tacking on the array of all of our messages. And then if data.value happens to be an object, we're wrapping that in an array. So believe it or not, that is all that we need to do within our shared worker today. That gets us up and running with everything that we need. So with that done, let's grab our mutation types here and let's jump back into our index.html and let's paste those into our constant values. Let's add our form event handlers. So document.forms.send message form add event listener for submit. Let's call a function called handle send message that we'll define here in a minute. We'll have another form for document forms clear messages form. Add event listener for submit on there as well. And let's call handle clear messages, which we'll define here in a minute. In addition to this, we also need to add an event listener for our workers on message event. So let's define that as well, right underneath our worker. So worker.port on message, and we're going to define a function called handle new message that we'll use for that event listener. Okay, so let's go ahead and define these three functions. So handle send message, which takes in an event for our form. We're going to event prevent default. We're going to grab our value from our message. So event.target.message.value. And then in a little bit, we will create and add our message. And then let's do event target reset to reset our form, and event target message focus to refocus our message input. Next up, let's define handle clear messages. So function handle clear messages. This will also take an event. Keeping with the way that we did local storage, we'll wrap this in an optional event property. If we have an event, then we will call prevent default. And then what we'll do here in a minute is clear our messages within our worker. And then lastly, let's define handle new message. So function handle new message. This is going to take in the event from our onMessage event handler, which we'll extract out data from. And remember, data is going to contain mutation, value, and messages. So let's go ahead and grab those real quick, just so we don't forget. So mutation, value, and messages, which will spread out of data. Okay, and then for storing our messages, we're just going to use local storage, but just note that that is not the method that we're using to perform our cross-tab communication. We're using it simply just to store our messages on reload. So let's set stringified storage item, pass in the messages key, as well as the messages that we send back from our shared worker. If we have any messages within our array, let's hide L our placeholder. Otherwise, let's show L our placeholder. And then very similar to how we handled our messages within our shared worker, we're going to use a switch on the mutation to determine how to handle the mutation type that we're doing. So let's do case mutations add to handle our add messages. And then in a minute, we will define a function called display messages, which we will run here. Let's break out of that and do the same thing for case mutations set. And we'll display messages there as well. And then in addition to displaying our messages whenever we're setting, we're also going to want to clear out whatever our message ordered list contains so that we get a fresh copy of the entire data set. So for that, let's do messages l.innerHTML and just clear that out as an empty string. and then we'll break out of this case, and that should be all that we need for handle new message. Okay, and then with handle new message complete, let's start fleshing out our handle send and handle clear messages. So for our handle send message, we need to create and add a message. So each message is going to have 3 different properties. It's going to have a unique ID, a sender ID, which is our tab's unique ID. So each new tab that we create gets its own ID that's persisted using local storage, and then our message is the third property. So let's go ahead and create a function to create those. So function make message, which takes in our message string, and then let's just return back an ID calling a utility function that we have down below called getUniqueID. And then we're going to have sender ID as our global tab sender ID value. And then let's just tack on the message as our third property. Okay, with that done, we can now create our message. So let's do const message equals make message and pass in the value within our handle send message function. And then really all that's left to do is send the message to our shared worker. So let's create a function to do that, since we'll be doing that in a couple different places. So function post message, we'll take in the mutation type as well as the value. And then let's do worker.port.post message. And then let's just send in an object of mutation and value. And then let's scroll back up to handle send message and let's finish this out. So post message mutations, we're adding, so we're going to call add, and then let's pass in our message. Give that a save, and that should be it for handle send message. And then for handle clear message, all that we need to do is clear out our messages. So for this, we could just do post message mutations.set and pass in an empty array to clear it out. Okay, and then the last functionality that we need to flush out within our function handlers here is to display messages. So let's go ahead and define that function. So function display messages. So take in messages that will default to an empty array should none be provided. We're going to loop over messages for each message that we get. Let's tack it onto our messages L. And then let's create another function to actually create our message element. So make message L, and then we'll just pass in the message for that. And then function make message L. And then within here, we're going to accept our message objects. We'll just spread that out so that we have direct access to each property as message ID and sender ID. Okay, now let's create our li. Const li equals document.create element li. Let's do li.id equals id. li.textContent equals our message. And then we're also going to add on a class name for this. And then if our sender ID for our message that we're adding is the same as our tab's sender ID. So if the message was sent from the tab that we're currently on, we're going to have the message be blue and aligned over to the right. If the message was received or sent from another tab, we're going to have it gray and aligned to the left. So let's define that logic here. So first and foremost, we're going to have an if-else ternary. And then we're going to have a base class for both of those. So const base class name equals px3 py1 rounded. And then let's define that for both uses of our class name. So when the message was sent from the tab that we're currently on, let's have the bg be blue 600. Our text will be white, and then we'll place self end since we're using grid on that ordered list. And then whenever it's received or sent from another tab, let's have bg be gray 700. Our text will still be white, and we'll place self start. And then from here, we can just return our li back. And then lastly, let's make use of our display messages where we have them commented out here. So display messages, then we can just pass the value in for both of these. So uncomment it and pass the value in. All right, cool. Let's give that a save and let's go test it out. So now remember, we need to refresh our shared worker. So let's close one of our tab instances, refresh the single one that we have left open, and then let's open up another tab instance here. And I'm just going to open up the console on that real quick. And let's try sending on a message. So test. Okay, and then it looks like I have a typo within my make message L. The E and L should be capitalized. So let's change that really quick. It's right there where I'm calling it. Okay, give that a save. We don't need to refresh our shared worker, so we can just refresh both tab instances, and let's give it another go. Okay, cool. So we can see test showed up okay on this tab, and let's check the other one, and there it is there as well. Since we received it on this tab, it's gray and to the left, and since we sent it from this tab, it is blue and to the right. And we can test it from the other tab as well, just to make sure it's going both ways, and you can see there, I should have used different string for that, but okay. Seems to be working. And now the last thing that we should need to do here is to populate our messages on load. So let's refresh and yep, confirm that that needs to be done. Now we can go over to our other tab real quick and just test to make sure clear messages is working. Seems to be. We can't test it on the other tab, so we'll test that in a little bit. So let's jump back into our code and get these loading up whenever we refresh the browser. Okay, so now to do this, we're going to define two messages. We're going to have a function to get our messages from our local storage. So let's call this get messages. Should have an S on it. And then const messages equals get parsed storage item for our messages key. And then let's return if it's not an array. Then let's return an empty array. Otherwise, we'll just return back our messages. And then above this, let's define function load messages. Const messages equals get messages. And now since we're storing our messages within our shared worker, we need to post these messages to our shared worker so that it has them stored for our mutation events. So let's post message mutations.set, and let's just pass in our messages. Okay, and then that should be all that we need to load in our messages. So let's go ahead and call our load message function. So we'll do that underneath our form event listeners. So load messages, give that a save, and let's go test it out. So let's refresh both of our tabs. Let's define some more messages. So testing, let's send one from this tab. Test 2, test 3. Let's refresh to make sure that that's working. And there we go. You can see we got testing, test 2, test 3. Do the same on the other tab. Okay, looks good there. And then let's give our clear messages a full test since we tried to test it last time, but we already had our other tab cleared out. So let's clear messages. No messages there, no messages there. Let's refresh. And it looks like we're all good. And that concludes how to do cross-tab communication using a shared worker. In the next lesson, we'll go over the same thing using a broadcast channel.